Alright, we had electron configurations. An electron configuration shows the arrangement of all electrons in their orbitals for an atom in the ground state. There are 3 rules to help explain how electron configurations work. The first rule is off-bound principle. Electrons will enter their orbitals starting with the lowest energy first, which is the ground state. The second rule, Pauli exclusion principle. 2 electrons in the same orbital must have opposite spins. The third rule is Hund's rule. In p, d, and f orbitals, each orbital must contain 1 electron before a second electron is added to any orbital. There are 2 ways to write electron configurations. One way is orbital notation, and the other way is sublevel notation. For orbital notation, you can show this by drawing the correct number of orbitals with as many lines as needed following the 3 rules, and you should probably use your chart. Okay, so for this example, we use carbon, and the atomic number for carbon is 6. So if you look at your chart, thank you, I don't know if you can see this, the first level is 1s, and in each orbital you put 2 lines, and each line has to go a separate way. So we put the first orbital over 1s, and you put 2 lines in that one. And in the second level is 2s. And so we go back up here, and you have another orbital above 2s, and you put 2 more lines. And in 2p you have 3 orbitals, and you can put 2 more lines in that. But you can't put 2 lines crossing in the first one because you have to fill out all of those circles. Okay. For sublevel notation, instead of drawing the orbitals, you write them out with numbers. So we used oxygen, and the atomic number for oxygen is 8. And so we go down here, and for the first level is 1s. So in 1s you can have 2 lines, if you remember from the circles, and so you put a 2 next to the 1s. For 2s, you can also have 2. So you put 2 lines in that. Okay, so then you go down to 2p, which is right there, and that has 3 circles, so you can fit 4 in there. So 4 plus 2 plus 8 plus 2, my bad, equals 8. The end! Woohoo!